Hello, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University. In this lecture/podcast, I want to be going over another important and kind of a hallmark sort of article that's over here. So the title of the article is Big Data in Public Health, Terminology, Machine Learning, and Privacy. And this was again written in 2018 approximately, and Stephen Mooney was the main author, and then senior fellow, another one was Vikas Bejavid. Okay, so continuing onward, just giving you kind of a synopsis of what was in the abstract, and usually some of the most important findings are in the abstract, so it's always good to start with that. So the big data have unlocked novel opportunities to understand public health. They hold still greater potential for research and practice, so we can more with fine-tune our application and understand where big data actually fits in there. So next we consider common public health research and practice uses for big data, including surveillance, hypothesis generating research, and causal inference, while exploring the role that machine learning may play in each use. So this is really interesting because it ties together surveillance and then looking at how machine learning then applies and plays a role in all of that. So quite a few layers in here, or onion skin, which we're going to go ahead and peel as we move through this article. So they're saying technology actually changes social norms, and I completely agree with that. When cell phones were not smart cell phones, you would be exclusively using it for phones, and then as the internet as it evolved, the internet was able to be accessed, then phones turned into internet. So I completely agree that there's important aspects of big data that has come about. Introduction, measurement techniques, data storage equipment, and the technical capacity to link disparate data sets develop. So increasingly large volumes, and then taxonomy is very important. What types of terms are used? So measures of participant biology, measures of participant context as in geospatial analyses, administratively collected medical record data that incorporates more participants than would be feasible. And that's where Fitbit data or GPS device can provide certain frequency intervals for participant measurements. Everything also, something that's striking is gut bacteria. By identifying variance patterns within these variables, you can actually do a component analysis, and has been done identifying patterns of gut bacteria. And then there's taller data sets. Category C and D may require more work to filter out irrelevant or low quality observations. And so when n is small, then there's different types of contexts that need to be considered. So the racial animus, social network structure, all of those. So omics is important here. Whole exome profiling, metabolomics, aspect of bigness, wide data sets have many columns, and tall data sets have many rows. So these are both worth considering. What's tall, what's wide. So geospatial is considered wide, and neighborhood characteristics and typical uses. Spatial autocorrelation, which is a technical issue which you have to actually go through before you can run a geospatial analysis type deal. So data cleaning, natural language processing, this is for electronic health records. These are very efficient tools which you can convert to electronic health records. Clinical research, surveillance are the typical uses. And then effluent data, Google search results, Reddit, which is TAL. Selection biases, again, natural language processing, surveillance screening, identifying hidden social networks. So this is considered effluent data. And so personal monitoring, that's I have a Fitbit too, and there's redundancy in inferring intentions. Electronic health records, TAL often, so we already went over that. So here's some more information that can be, and this is vocabulary that can be used, and Table 2 goes into that. And there's supervised learning structures, and this is k-means clustering, retrospective event detection, content analysis, k-nearest neighbors clustering, naive Bayes, neural networks, and support vector machines and decision trees. So again, these are extremely important and wonderful sources of measurements, which is something worth looking at. And then also lasso is an important one, least absolute shrinkage and selection operator. So when you try to run an analysis, sometimes the shrinkage is too much, and so you have to fix for that. So downstream exposure of interest can be used to estimate the causal effect of the downstream exposure. Again, literacy rate, that's something that's provided here. And this is a significant paper and quite vast in what it explains. So I encourage you to go through this. There's even a sidebar and a very important resource if you're just starting to learn something like this. So I encourage you to take a little bit of time to go through this paper and then try to understand the fine nuances that are being explained in the conclusion. I think the future directions in machine learning for big data and public health, I think that's one of the more important ones as well. So just take a moment to go through this. Thank you for listening.